Okay, ladies and gentlemen, we're back, and I want to do a nice little twist on a problem we did previously. This is one that's somewhat complicated, but you gotta get a good understanding of what's going on in it. Like anything else, if you get a good understanding, it's okay. All right, we did a problem in the last video that was similar to this. It said sine of an angle, cosine of an angle, minus 2 cosine of that angle equals 0. I put a little parentheses here for the angle. But the angle there before was just a regular angle, and our job is to find all primary solutions of this equation. Now notice I didn't write the angle in, because before the angle was just a regular theta. Alright? This time it's not a regular theta, it's a 3 theta. Yeah, I know. It looks a little complicated now, and some of you are probably thinking, well, that's no big deal. We could just use our double angle or sum angle formulas to break this, our sum angle formulas to break this down. But if you do that, guys, it's a giant mess. It's a giant mess. But there is a way we can handle it. We'll just use the same methods as before. You see a cosine of 3x, 3 theta. Let's factor it out. What are you left with? Sine of 3 theta. Minus, what is that? Minus 2, it looks like. That equals 0, right? Alright, well, if that's the case, let's get ready to rock and roll. Well, then we factor this out. We say cosine of 3 theta equals 0. And then sine of 3 theta minus 2 equals 0. And you solve, right? I got really excited there. Now you ask yourself, when is a sine going to be equal to 2? Obviously, that never happens, because the biggest it could be is 1. But this is the guy I want to investigate. So if we could solve this equation, we're good to go. So if you guys already saw this, I'm about to get rid of this, and we're really going to talk about what happens here. Okay, so recall cosine of 3 theta equals 0. When we were graphing this, what did the 3 mean? Okay, or maybe I should show you just how to do it instead of just, and then we'll talk about the theory later. So in order to do this guy, you can't just do one revolution. For each number k here, 3, 4, 5, 6, that's how many times you need to go out. So before, let me draw my unit circle. Okay, the first time around, you gotta ask yourself, where's cosine 0? Pi over 2 and 3 pi over 2. What I'm telling you is that because of that 3, you need to go around 2 more additional laps. So on the second lap, when you get to the top, this means that this guy is going to be 5 pi over 2. How did I get that? I just added 2 pi. I added 2 pi over 2. And that's what gave me that. Right? Because it's the second lap. And then on the end of the second lap, this side, same thing. This guy is going to be 2 pi is 4 pi over 2 is 7 pi over 2. And then not only that, I need to go around one more lap. One more lap. Okay? So I'm going to do another lap around. But when I get to the top here, it's not going to be 5 pi over 2. It's actually going to be 9 pi over 2. And then when I come back around this way and get back down here, it's not going to be 7 pi over 2. It will be 11 pi over 2. And all I did was add another 2 pi to each one of these. Okay? So now the question is what the heck did I just do all this for? Well, the reality is that 3 theta makes this thing go 3 times as fast. And they ask us for the primary solution. That means all of our answers have to be inside that first lap. Well, good news is this. If you look at this, 3 theta makes me go 3 times as fast. Here's the first 2 pi. So let's pretend I take this circle and I pull out all the laps and I make them stretchy straight as a string. Here's my string. Here's the first piece of my circle. Okay, from here to here is 2 pi. And then my next color was red, so let's make it red. And then here's my next lap. That thing is 2 pi. And then the next color is green, Christmas time. From here to here was also 2 pi. And then you told me that then we went through the work and we saw that they were points. And that's pi over 2 and 3 pi over 2. That makes this true on the first lap. Then there was 5 pi over 2 and 7 pi over 2, right? And then there was 11 pi, 9 pi over 2, and 11 pi over 2. And then you're saying to yourself, well, those are just the answers. We're done. Not quite. These are the answers for 3 theta. So I'm going to write them all out here so you see them. 7 pi over 2, 9 pi over 2, and 11 pi over 2. Those are all the answers for 3 theta, not theta. And remember, we have to be inside of 1, 2 pi. So what ends up happening here? Well, we're going to do this. We're dividing everything by 3. And this gets us some numbers. Now, I'm just doing dividing by 3 to make it nice, warm and fuzzy inside. Most of the time what I'll probably do is multiply by the reciprocal. It makes things way easier. But what does dividing by 3 do? Well, remember, this is a total from here to here is 6 pi. Well, divided by 3, what do you end up in? We're back in 2 pi in this range. But this is what happens. 1/3 of that is in black. The other third of it is going to be accounted for by this red guy, which is supposed to symbolize that second lap. And then finally, the last third should be in green, which is this other guy. And guess what? When I simplify this, I end up seeing that theta is pi over 6, 3 pi over 6, which is just 2 pi, 5 pi over 6, 7 pi over 6, 9 pi over 6, which is just 3 pi over 2, and 11 pi over 6. Notice all of these are less than 2 pi. So let me see if I can move this out the way. I guess I cannot. So you're going to have to deal with it. So that means here and here, this is pi over 6, 3 pi over 6. Here and here is 5 pi over 6 and 7 pi over 6. Here is 9 pi over 6, and last but not least, 11 pi over 6. And notice it's all within 2 pi. Okay, and that's the big key here. Okay, big key here. So no matter what this number is, if they had a 4 there, I would go out 4 laps, and then when I divide it by 4, it'll bring me back in within 2 pi every single time. All right, so that's basically all it is to it. Think of it as just like a piece of elastic that's stretched. And what you're going to do is unstretch it. When you unstretch it, it brings it back in, and it tells you what's going on. Okay? So, absolutely great problem. Absolutely great problem. Let's do one more. One more. This one will be more basic. So, let's solve writing all non-real solutions. Oh, not non-real. Wrong class. Writing all primary solutions. Primary solutions. That's all within the 0 to the 2 pi. Okay, so what do we end up with? We end up with this guy. We end up with, how about tangent squared? Oh yeah, it's getting troublesome now. Of 2 theta. That means we're going to have to go out 2 laps, ladies and gentlemen. Plus 3. Right. Yeah, I think that'll work out all right. So I made it off the top of my head, but I think it should work out okay. Actually, that doesn't work out very well at all. Let's make this 3 instead. Let's make this tangent squared of 2 theta plus 3. Just make it a straight even plus 3. No, minus 3 would be better. I know you're probably saying that you don't want to look at me redo the problem, but it's okay. It's good for you. All right. So now, first things first, what do? You say tangent squared theta, 2 theta, and you're going to add it over. All right? Well, guess what? That's tangent squared. We need to find tangent, so we're going to square root both sides. Now, check out what happens when we square root stuff, guys. Plus and minus. Congratulations, we have actually 2 things we need to solve here. I need to figure out where tangent of 2 theta is negative root 3. I need to figure out when tangent of 2 theta is root 3. Now I'm going to cut it down to layman's terms. Once I figure out where it is on my unit circle, I can go ahead and solve. Now, good news is I know my unit circle real well, as the rest of you should by now. Okay. Consider these points. Let's look at the first one. Where's tangent negative? Tangent is negative in 2 and 4. So here, if you look at consider this point, which is root 3 over 2, 1/2. And the x is negative, and then you got this point right here, which I know for sure is root 2 over 2, root 2 over 2. X is negative, and you got this point right here, which is, what is that? And the reason why I'm doing this is because I have to divide the y by the x. So if you're not totally sure, do this, and eventually after a while you'll know what the answers are without even having to do much work. So I kind of see that the angle I need is this guy, because when you divide the y by the x, it gives me the negative guy that I need. So what's normally living there? So this tells me that 2 theta, the first guy, is 2 pi over 3. Yay. Now, what's the next guy? Well, I can pretty much tell you it's probably going to be this creature right here. Okay? Shoot, I did it again, didn't I? It's probably going to be this creature right here. Now what is this creature? Or maybe it's right here. I'm not for sure. Let's just draw the point, make sure we're okay. We get 1/2 root 3 over 2. The y is negative. Yep, it's this creature right here. So that's 5 pi over 3. That's the first revolution. Okay? This guy, and I'll cut to the chase and do this guy a little quicker just so I don't make the video too long. This guy ends up being the exact same quadrants, 1 and 3. And this guy is actually positive. See how these guys are over 3? The other guys are over 3 too. This guy's over is pi over 3 and 4 pi over 3. This is just the first revolution. So we're going to add 2 pi. Now I'll show you a trick. See how the denominators have a denominator of 3? 2 pi is really 6 pi over 3. So if I add 6 pi, we'll end up with 8 pi over 3. And another 6 pi is 11 pi over 3. Went out 2 laps. Same thing with this one. This guy ends up being 7 pi over 3. 10 pi over 3. Next, divide everything by 2, which really means multiplying by a half. So you get pi over 3, 5 pi over 6, 4 pi over 3, and 11 pi over 6. How do I do that? Well, multiply both sides by a half and distribute and simplify. All right, let's do the same thing here. Theta is going to be pi over 6, 2 pi over 3, 7 pi over 6, and last but not least, 5 pi over 3. So we got 8 answers. 8 answers for how this guy can possibly be correct. And note, all these answers are less than 2 pi. They're in that range. They're in that range to be called a primary solution. It's very, very important. Okay, so it's handling a double, triple, quadruple angle when solving. If all the angles are the same, you don't have to go out the way and turn them all into a single angle. Sometimes that is so exhausting, it'll drive you crazy. So how do you deal with it? Isolate for it. Think about it. Just go out for an extra how many laps you need. And then when you divide by that number of laps, you'll end up getting back within that 2 pi. All right, guys. This should finish up the rest of chapter 7.5. And next time we talk, will be inverse functions. Remember, in order for us to go somewhere